Okay, thanks, Mike. Thanks for having me. I work at Box, which has been around longer than Dropbox, but you probably are more familiar with Dropbox. So we're Dropbox for businesses, even though they're trying to do businesses also. But so we're kind of storing an enterprise's a business, an enterprise, whatever, their stuff in the cloud, helping them collaborate, adding security, all the roles and sharing and all the things that companies care about, but want to make sure that your data is still, inside the company and not leaking out very much. So I'm going to talk about Scalaz. I do have we can go into the REPL if anyone wants to really get some code going, but I have lots of code on the slides. So being passed out right now is a cheat sheet for Scalaz that really just has the basics that I'm going to talk about in my talk here. So follow along or put it on the side and save it for later. And then there's a link at the end of the slideshow to where you can find out more information. So questions anytime. I can go somewhat deep, but I want to make sure I cover just enough material so you feel like, oh yeah, I can do this. I can get into it. We are hiring at Box. So Scalaz, it's a library that you can use. And I stole this from a different Scala talk. It's not mine. So it has this reputation of being this mind-blowing, oh my God, only crazy neckbeard wizards can use it, whoever they are. And a lot of that has been because it's not documented very well, and the community tends to talk in a lot of high-level abstractions that have meaning but are not necessarily, you don't know it until you know it. Just like if I talked about differentials or integrals, it won't make any sense unless you took calculus. So it's just kind of, there's a bar, and some of it I'll never get to because some of it is really wacky and crazy, but has deep meanings sort of mathematically. But I'm going to try and get you guys just to level 1, whatever level 1 is, where you can actually use it practically. So that's my goal. So we're not going to talk about monads and functors and applicative function, all this stuff. That happens under the hood, and maybe after the talk, if you're interested, we can talk about that stuff. But I'm not going to say this is a definition of a monad or anything. Instead, this is going to be about everyday situations that we all deal with all the time. So it would be I'm assuming we're all a Java programmer or some sort of object-oriented programmer, because that's usually what we do, where we start with, what we've evolved to, and what we use regularly. And so I'm going to just take examples that from everyday situations that you could now perhaps use some of Scalaz's stuff for. So hopefully that will be useful. Okay, so how do you get into Scalaz? Well, this is for SBT. Probably everyone who's used Scala uses SBT. So SBT is the same ideas as something like Maven, where you can have a dependency. This is the magic string to say, I want Scalaz, and I'm going to be talking about Scalaz 6. There is a Scalaz 7 in the works. It has slightly different APIs. It's not quite at a full release yet, so I'm still going to talk about Scalaz 6 in case it matters. And then in your code, it's really easy to use. You just do this, and then you get all this stuff for free. So there's the first magical import, and that imports the uppercase version, and then you get everything inside the uppercase version. And you can use all the stuff that you want. So the first sort of tangible subject I'm going to talk about is memoization. So sort of back to computer science 101 or whatever, we have some expensive function. It does I/O, it's some fancy algorithm, and it's expensive in some way. And every time we give it the same input, we're redoing work that is expensive. So the basic idea is, well, okay, I'm going to just cache. If for every input I get the same output in a normal functional language or anything, I get the same answer. That means I only have to compute the answer once. and then I can save it somehow, so I don't have to do it. I'm trading space for time. Pretty much everyone has done this all the time. So in Scala, you might use a map, a mutable map that you can add stuff into and take stuff out of. So the syntax of it is a little bit, it's kind of verbose. You have some cache, and you say, give me the thing with key F, and in case you don't have it, here's the function that will produce the value that I want you to stick inside of the map. So that next time when you look up in the map, it doesn't cost very much to get it. It's just a lookup. And kind of maybe one of the downsides of the previous version is you might want if you're using a cache, sometimes you want it to not look like a cache. Like you have to use a different syntax. Sometimes you want to hide that. So maybe you try and be a little bit tricky and treat that map as just a function with the same signature as the expensive function. And so you might try and do it. I was trying to figure out a way to do it, and I found this with default method that you can call on the map constructor, or just any map. And that gives you a new map that if the key is missing, it'll call this function to look up what the value should be. But that actually doesn't cache. So don't do this. I was just trying to find a way, like, how can I make the cache look the same as the expensive function, type signature-wise? So in Scala Z, it's really easy to make one of these caching things. So there's the expensive function, and then there's this constructor-looking guy, immutable hash map memo that says, OK, under the hood, there's going to be an immutable map that somehow gets updated. We don't know how. It's just sort of the name of it's the factory method. And I pass it a function. And that function takes a foo, just like my expensive function. And how do I get the answer to what foo is? I call expensive foo. So, and that's all you need to do. Under the hood, you call this new memo thing, which really just has an apply method. So like in Scala, a lot of things that just look like function calls are actually calling the apply method on something, if you're familiar with sort of the basic Scala idiom like that. So it's just a function call like the expensive. So if I give it the input, and it's not in the cache, so it computes the real answer. And then the next time I call it, it's really cheap because it's in the cache. So it's really nice because I didn't have to use a different kind of method, the get or else update kind of thing. But the sort of naive way of making the signatures the same, this is a function from foo to bar, and my memo is also a function from foo to bar because it has an apply method in it under there. But it's just much easier. Does that make sense? Pretty easy. You give it a function, and it memoizes that function. So then Scala Z has different strategies that you can plug in. Maybe you don't want to use an immutable map because inside the machinery of Scala Z, you're always reassigning a variable or something like that. You don't have to worry about it, but Scala Z does. Or maybe you want to use a weak hash map. So a weak hash map, there's a weak map in general, will throw away the values if no one else is referencing them anymore. So it's a cache that with normal garbage collection, if you don't need the thing in the cache because no one's using it anymore, then it'll eject its entries and you're not wasting memory. That's another sort of common thing you do in, say, Java. You use a weak hash map for sort of caches, sometimes. And then maybe you have a fixed size cache. You have a buffer of some kind, or you only store 1,000 entries, and you can just use this array memo constructor to wrap a function, and you'll only hold. It's indexed by integers, so you could do some tricks to say, it'll hold 0 through 999, and you could then map other ranges into that if you wanted to. So it's pretty versatile. I use it a lot in my code, and it's just easier than changing the signatures around and doing stuff. The downside, I guess, would be there's less low-level control. If you're actually using you want to have some sophisticated strategy, perhaps Scala Z doesn't provide a basic thing, but a lot of times you just want to have a map backing something, and you don't care. Everybody okay with that? Good. Yeah?
I just had a question on the immutable
Yeah.
What's the thinking behind that? Are you able to go back in time to a point when certain things were cached?
No, I mean, I think it's just, there's different performance characteristics. So in the implementation in Scalaz, there's a var that gets reassigned with a new immutable map when you update it. And if that is affecting you or you don't like that, you could use the mutable map version, which would be stored as a val. And so it's just kind of like, well, I can only guess what the authors, why they chose it, but it's sort of just, here's a couple implementations. There's also a constructor where you can make your own memoization stuff too. So if you want to implement some fancy caching scheme, you could plug it in, and then you can make your own memo constructor that looks just the same as all the other ones. So kind of flexible memoization.
What version of Scalaz are we talking about?
This is Scalaz 6.
And does that matter for this?
I don't know Scalaz 7, so I don't know if I can answer the question. But I think most of the stuff in Scalaz 6 is in 7. They're just kind of reorganizing it a bit. OK. So now I'm going to go into some just little stylistic things. We all want our code, well, you should want your code to be easier to read. And sometimes it gets a little bit hairy, whether it's lots of levels of indentation, and maybe you want to break that up, or you want to sort of reverse things, or things just, if things just look ugly, maybe there's a way to make it better. And Scalaz provides a little bit of nice little touches to improve Scala that I think are kind of cool. So one example is like temporary variables. You have a function that takes an a to a b, and a function g that takes a b to a c, and then you have a value a, and you plug it into f, and then you plug it into g, and you get a c back out. So you could make a bunch of vals, and people might justify that like, oh, well, I might want to log b, so I'm going to just break out this computation in multiple steps, and usually it's never really done. You don't end up doing it that way. So then, OK, I'm going to be smart. I'm just going to make this composition of functions. I'm going to call f, and I'm going to wrap it in a g, and I'm going to wrap that in an h, and blah, 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 blah. But it's a little bit hard to read. You get sort of parentheses-itis, and I'm going to argue that sometimes it's hard to read. Sometimes it's not. But there's this cool little squiggle operator thing. I don't know the name of it, that lets you kind of make it look like a Unix pipe. So I have an A, I'm going to shove it into F, and whatever that produces, I'm going to shove it into G, and that's going to be the value. So you can decide for yourself if that's interesting. It's a really tiny little thing. You can look at the implementation, and it's like 7 characters of how to do that, But it may make certain parts of your code more readable. So think about it. I'm not saying use it everywhere. Then there's things that Scala doesn't have that a lot of people wish they had. So like the ternary operator, like in C or Java. Does Java have it? I don't even remember anymore. Yeah, it does. So the question mark, colon, you give it a Boolean, and then if it's true, it takes the first thing. Otherwise, it takes the second thing. So Scalaz lets you do that kind of thing. So rather than a colon, it uses a bar, a pipe. So that's kind of cool. You can do that. And then for the option class, if an option can be some or none, if it's none, you can say, well, if it's none, use this other thing as a default value. So rather than kind of that long-winded version, you can just say, oh, pipe, default value. And I would say it has fairly low surprise what that means. But you could also, you might not know what it means, but you can always hover over it with your mouse in your IDE and see, oh, what is that thing? Oh, it's get or else, I see. So these are the most handy of these things. Some other quick ones. So there's like the constructors of option, and the next slide is the constructors of either. So you end up putting the type on the outside and the value on the inside. If you want to use a more this dot that dot whatever kind of syntax, Scalaz provides that. So rather than some foo, you can say foo some. Oh, I'm sorry. Side question?
No, I'm okay. I just wonder if you can nest the short keys that you showed.
Nest which ones?
In a clause, in a then clause, can you nest an
With parentheses, sure. That's the problem with the precedence, yeah. Yeah. So you can use some simpler shortcuts for these guys if you like this. And then, so for either, there's the same kind of thing. Rather than specifying, right and left of these things, you can say 42.right. And then you can, because sometimes we have these types inside these other things, so you might want to say 42.right.sum, and then that's a sum wrapping a right wrapping an int. So try it out, see if it looks better. I like it for only one reason. The one reason is it's a lowercase. It just kind of looks nicer than that version. I mean, that's bold, so it's not really a fair comparison, but lowercase is a little bit nicer to read, says like the Ruby people. So you can make your code a little bit more expressive. You got to know what these things mean, like the pipe greater than guy that is function composition. But they're fairly low surprise stuff. Now, some of the arguments against Scalaz is there's a lot more of these things. There's like a star operator, that Z Shaw, bad word, something or other, and those are kind of crazy. But it's like calculus. If you don't know what the big S is, it's scary. But once you do, it's like, okay, I know what the big S is. It's not a big deal. These are the ones that are sort of low surprise in the general sense. Yeah.
Does the composition thingy handle multiple arguments, or the function composition?
You probably can, if the input is a tuple, then it might just auto figure out that that's the 2 parameter of the next guy. You had a tuple 2 with a 2-arg function, or a tuple 3 with a 3-arg function. But we should try that afterwards, see if that works, because that would be the way to do it. Okay, so this is going to be the most difficult part, but it's going to make sense because we do this all the time. So here's an example of something that we do. It's not a great example, but it kind of shows the spirit. So we're always creating some representation of these objects in the real world. So like a social security number. It's made up of 3 digits and then 2 digits and then 4 digits, I think. But how do I say I want the second one to have 2 digits as a type? So I can't do this, right? Oops, what are you going to do? You don't want an input like that. And we have all these strategies to deal with it, and I'm going to try and show you one that Scalaz provides. So another example, a version. Oh, no, I put the minor version as -1. That doesn't make sense. Or this is like a code dependency. So I depend on this thing, but I'm passing an empty string in, and I can't. There's no real way to say I want a string that's not empty. In our languages. So there's always some kind of runtime check or something, and then it blows up, and then what do? We're always handling these kinds of situations. No, so we got to figure out a way how to do this, and there's sort of good patterns and not. So this is sort of how I view like what we normally do, especially in like a Java world. But this is the Scala version. You blow up when something doesn't work. So this is our version class, and we want to make sure that the major part and the minor part both are greater than or equal to 0, because it just doesn't make sense to have a negative version number. I hope we can agree on that. So require will throw in a runtime exception if the condition doesn't match. And then, so you can imagine, well, if things don't match, it's going to throw an exception, so the thing that's making this, do I need to wrap it in a try-catch? Sometimes I do want to, and sometimes I don't, because it should never happen, and it's hard to decide when that is, I'm sure we're all ear nodding. I mean, we do this all the time. We get inputs from the outside, and we're trying to jam it into some data structure. And some things, it's okay if they don't fit, and it's really important that this fits, and we get confused. So, right, so like in the require example, if the major was bad, we're going to throw an exception. But the minor could have also been bad, and we'll never know. So it's kind of like, I really want the most context possible for what's bad, rather than just failing fast. Although failing fast is great because things blow up. As long as you can guarantee that you get all the errors and then blow up, that's good too. What else does it say? I can't read that far. Yeah, catching exceptions, we all hate it. Like you have nested ones, you have to decide which exceptions I'm going to handle now, otherwise I'm going to rethrow them. Do I make my own exception type, or do I use the Java ones? Is it an illegal argument exception, or is it an illegal state exception? And I don't know. We all have our patterns that we've developed over time to do this. So I'm going to talk about the Scala Z way. So I'm not going to introduce the types yet that you'll use, but this is kind of the general picture. So what if we had this, so we have an input major and an input minor, and we want to create a version from it. So what if we had this function called validate that takes the inputs and then tells us something about those inputs and how they make the thing that we want, the actual version. So you could imagine that, well, the thing we got from validate wasn't good. It had something bad in it. It had a negative number in it or whatever. And we want to provide a default value. So that'd be kind of cool, kind of like option. Like I got a none and I want to give a default value. So maybe I want to give a default value if the inputs to my thing were bad. Or I want to do a kind of a pattern match and handle each individual case. So I got failures, I'm going to do something. Or I got the actual thing successfully, and that's my version class, and I can move on. It's equivalent to a try-catch without, but a little bit more succinct, I would argue, rather than curlies and all this stuff. I'm going to fill in that question mark there. So in Scala Z, there's this validation class. And just like option has two subtypes, some and none, either has two subtypes, left and right, validation has a very nicely named success and failure. So when you validate something, you get one or the other. And so if you get a success, it's the object that you wanted from the inputs. And if you have a failure, it contains some representation of what went wrong. And typically that's like a list of strings that describe the bad condition. That's like sort of what you might expect. Just like an exception, the default behavior or the default data of an exception has a string in it. And then maybe you might make a subtype that has extra stuff in it. So those are the types. And then, so now let's try and implement this constraint. I want to make sure that the digit is greater than or equal to 0. Pretty easy. So all we need to do is really just have this Boolean test. Is it greater than 0? If so, I'm just going to return the digit. Because, and so let me pause for a second. So a valid version means a valid major number and a valid minor number. So the smallest unit that we're going to work with is this number okay? And we're going to do that on the major part, and we're going to do it on the minor part. And then we're going to combine them together. So I have a Boolean test. If the digit is okay, then I just use that syntax like before, like .sum or .right or .left. I'm going to call that digit a success. And this is just for the typing of the failure side. So I'm going to return a validation. That's the super type. And if it's not true, and I'm using the ternary operator kind of thing, and if it's not greater than or equal to 0, then I'm going to return this failure message and sort of wrap it in a fail, which is the failure type. So the general type is validation, and then on the left-hand side is the failure type. How do I describe what's wrong? It's going to be a string. And the right-hand side is the thing that is what I want if everything's okay, which would be the digit. Does that make sense? All right, Mike.
I wonder if everybody knows either.
Either, left, right. See, those are confusing. Like, well, once you know, but the convention is right is right is correct, and left is not.
It's gauche.
It's gauche.
How is that different from either?
It's not. That's a very good question.
So
It's exactly the same. It's either one or the other, just like either is. Either is left or right, and validation is success or failure. But it's just got some extra stuff in it, which makes it cool.
And better names.
And better names, exactly. So you don't even have to use the so-called fancy stuff. You could just use it for better names, which is nice. Or you could just say type, blah, 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 and alias it yourself. So now we have this function which validates a digit. That's good. So now we need to validate the major part, and we need to validate the minor part. And so there's this code that I'm going to hand wave around, and I'm going to say, yes, you do not understand what this means yet. But conceptually, I'm just going to be like, okay, if I don't know anything, I'm validating the major digit with a bunch of garbage, and then I'm going to validate the minor digit with a bunch of stuff, and I'm going to use this thing, which has no name, but I have a name for it.
It's called the Home Alone fix.
Yes, but I have a better name. My proposal is it's the Admiral Akbar operator. What do you think? He likes it. It's a layered joke. Okay. Because it's an A, and Admiral Akbar is kind of weird looking. And it's a trap, yeah. This code is not a trap. So I validate the, yeah.
And what, out of curiosity, does NAL stand for?
I'm going to talk about that too. So this is where we all get lost, and I'm going to try and make sure that we don't, because it's confusing. So I validate the major and I validate the minor with the Admiral Akbar here, and then it looks like I give it a function because functions have curly braces, and then this looks like a constructor of the version object, and this means I don't know what these things are yet. So this is like a function which takes a version, yeah? So this is a 2-argument function that produces a version. So if I'm validating the major and I'm validating the minor, then somehow if those work out, if those are both successes, they're going to get passed into this function. And then I'm going to have a validated, successful version. And I'm going to break this down, but that's kind of like if you zoom out, that's kind of what's happening. That's the idea of this code. So I'm going to break down what this thing is. So if I just use what we had before, valid digit, that produces a validation where the failure type is string and the success type is int. Okay. Then there's this LiftFailKnell thing. So this is it's not quite an acronym, but it's a shortening. So you don't have to know what it totally means. And I'll explain it 2 different ways, and we can also talk about it later, like what the hell's going on. But lift is like, okay, I'm going to do something. So the validation holds something. It's going to hold the success or failure. So I'm going to do something inside of that thing. We can just say lift means I'm going to do something inside. And then fail means I'm only going to do something inside the validation to the fail side. If it's successful, I'm fine. Don't do anything. And then Knell stands for non-empty list. So it's a shortening with an acronym inside of it, which is confusing. And the only thing you really need to know about non-empty list right now is it's a list that can't be empty. Okay. That's all it is. That's all it is. And there's sort of, I don't know why it's this way. I can surmise why it's this way, but just think of it as a list that can't be empty. Because you can have an empty list if you just use the normal list or sequence class in Scala. So if you say list.head, it might throw an exception. So then you call head option, which gives you an option, and blah, blah, blah. So what if you could have a list that was never empty? That's cool. Okay. And that makes sense, too, because if something's failing, there's got to be something. Okay, so that's the whole reason for this LiftFailKnell thing. So what does that actually do to the first type? So all that does is it takes a validation string int and produces a validation where the failure type is now non-empty list of string. So string goes to non-empty list of string. That's all it does. So just like you might have string to list string, same thing. And so this list, if it was a failure, just has one thing in it. And the reason why we're sort of turning the failure side into a list is because if the major side was bad, then maybe the minor side was bad and it has its failures, and you want to collect all of them. So you just append those lists together at the end somehow. Whereas if you kept the type as string, what does it mean to combine two strings? You might like concatenate the strings together, and then there's no new line between them, and it's just kind of weird. So that's sort of this weirdness, this little bit of extra overload to everyone's head, like why you have to do this. Yeah, you had a question.
So in this situation, the errors are all string.
Yeah, yeah. That just to make it easy. But it's a good idea to make them strings. People understand them. You can print them. Yeah.
If they weren't all strings, could you combine them in the non-empty list?
Yeah. Your failure side could be anything. Like if you were like a super nerdy, you'd make a status code. And then the failure type would be status code, and you can make, it would be like an enum or something. And then those could have a string version, but could have other information in them or something like that. Yeah, yeah. Any sort of, bad stuff. You could have string and the latitude, longitude, and the, whatever. So we validate the major part, and we turn it into the failures into a list just to make it easier to collect the failures later. We do it on the minor, so they're both this validation string int. And then there was the thing in the function, in the function part, which is like a function that takes in two ints and produces a version. So the way to read that statement from before in kind of a condensed way is that I put these validations together with Admiral Akbar, and I give it the function, and now I've combined two validation nels string int together, provided a function that takes those two ints into some other type, which is version. And now with this bit of syntax, now I have a validation of a non-empty list of strings of version. So I've combined the two ones that take ints, that produce ints if they're successful, and now I have a thing that validates a version. And so in the end, I get a version object if it's successful. And if there were any failures along the way, I get them all collected in the left-hand side as a non-empty list of strings. How's that? Yeah. Right. So yeah, that makes sense. So if there's strings, you'd have to put in the string. So non-programmatically, you couldn't know it if they were strings unless you parse the string. But you could, in your error message, you could say major was bad and minor was bad. Or your error type could be, something that indicates what it was and a string description of that to be more specific. That's kind of what I would do. Yeah.
And so we have the original inputs in the non-empty list, the string and the input, or the integer. What's the integer? The second argument, the integer on the validation non-empty list string integer.
So
third line.
Uh-huh.
Int.
Yeah. So the int is the digit that we're trying to validate.
Okay.
So if it was a 1, it would be a success of 1.
So you have that still on failure. You have that original input.
Yeah. We're just sort of we give it an int and we're producing a validation of string int. So it's going to hold the original input. But then later we don't have the version we're validating. We're combining the two ints and then giving it a function that takes those two ints to a version, and then that's sort of happening inside of the validation. Yeah.
Maybe explain what, like, if you want to preserve that original input as part of the error, you have to do that still.
Yeah. Yeah, so that could be as simple as the error type would be it could just be int, and then you'd have a non-empty list of ints, but then you don't know what it was major or minor, and then maybe it could be a tuple where it's an int and a string, and the string could sort of say what it was, or you have some encoding, of the name somehow,
You would do that in the valid digit,
in the thing that produces the validation, yeah.
which is the valid digit.
The valid digit guy, yeah. Yeah.
So just wrap it in a pair.
That's the easiest way to do it, yeah.
Yeah, okay.
But then, I mean, that gets into like, well, how do I refer to the name of the major field versus the name of the minor field? And you can go down the rabbit hole a bit. But yeah, if carrying along the original version is no problem in the failure case. You just sort of tack it on to whatever the type is of the failure. And a tuple will work fine.
I think where it just has a problem is if they're two different types, right? So then you'd have to go back to an any or to an any ref or something. If one of them were an int and another one were a double or something like that.
In the success side or in the failure side? In the failure side?
Failure side.
Yeah, so you'd either generalize it or maybe you make your own. Yeah, then it gets complicated.
You could do a pattern match or something.
Yeah, any would be a little too vague, but maybe you just pass along as an any, and then somebody who's receiving this thing in the end could then try and figure out what it actually was.
Right. Which, I mean, generally, you're just going to print an error message. It's not necessarily.
Strings are good. Just at least start there, and then see what else you can do. So kind of the general pattern to back up is like I have these basic the parts of the subparts of what I want to validate, and those are validations. So there's a failure type X and a success type A, and then there's another one of these that has the same failure type, but a different success type. And then so I have an A and a B, and so in the success case, I get the function that I pass in is how do I transform the input successes into an output success? So that would be A to B to C. And then analogously, if I had 3 validations, I connect them all with Admiral Akbar. I provide a function that takes the 3 success types into the final success type, and these guys will be concatenated together in the failure case. And kind of the rules for that, like the truth table, like in Boolean logic, is if you had 2 successes and you Akbar them together, you'll get a success. And in any other case, you'll get a failure. And if there's 2 failures, you make sure to add together, for some definition of add together, their failures. And that's the reason for this Knell thing. You could use a validation of list of something, and lists validation knows how to put lists together. So there's kind of a lot of assumptions built in to this validation guy. I forget if I haven't a bigger. Well, yeah. So there's a lot of assumptions built in. You got to know. There's the immediate gains, like just the type name. It's a bit easier to understand. We have to make sure that the failure types can be added together somehow. And the normal way is to use this non-empty list thing, which is just a list. So once kind of those things get in your head, then it's not so bad, I hope. I hope you can agree with me, and we can do some more examples maybe after the talk to kind of get a feel for it. So in the end, you have a success or failure, and you can deal with it just like catching exceptions, but it's easier. You collect all the errors rather than failing fast, so you get a bit more context of what's wrong, and it's pretty cool. And the other thing I guess I mentioned is, to produce a validation is just a function, so it's really simple. It has some inputs, and then the function spits out a success or it spits out a failure, and that's all. And then you use the Akbar guy to combine them together with a function that handles the success case, and that's how you sort of build up the validations into larger ones. They like to say, it composes. That's the fancy word. but that doesn't mean much unless you know what it means. Yeah.
If I was to do something like this, I would just use a MapReduce type of methodology.
I mean, it's kind of the same in a way.
I'm actually,
Yeah.
it seems it's very similar, because I was thinking basically, because, you know, if you look at a browser, it has 800 version numbers on it, you know, 1.9.17.BC, and so if I start adding more version numbers on it, you know, expanding this to the tuple of 10 would be an absolute pain in the,
Right.
but it's essentially,
Yeah, and then
essentially a MapReduce in conceptually then.
yeah, so you can also contrast it from for comprehension. So like if you had a list, if you said for element E in arrow list, so that'll iterate over the list, and then you say yield whatever, so it'll pass the element for each element. It'll pass it into the thing after the yield, but it won't invoke the yield if there's nothing in it. And then if you stack those together, so if you get stuff from one list, the A list, and you get all the A's, and then you have another list and you get all the B's, and then you do the thing at the end. If there's nothing in A, you'll never do anything with B. So the for comprehension in Scala is fail fast, right? And you rely on that in your code to sort of not do work that you don't have to. And so the bar at bar operator is the non-fail fast version of that, if that helps also. I think you was first and then you.
Just as a quick note, the either is an unbiased data structure.
Yes.
So the point being, if you're doing a for comprehension, you want to get a value out, and you're making the assumption that the right-hand side is the correct value, you have to say, give me the right value from it. Whereas the validation is a bias structure, it's going to be biased towards success. So,
which is under discussion also.
yeah.
So if you threw a validation into a for comprehension, it would only sort of continue to the other parts of the computation if it was successful. Whereas an either, you can't put it in a for comprehension directly. You have to say either dot left or either dot right. So I'm just repeating what you said. Go ahead.
So in your validation pattern, middle and module object, and I was wondering if rather there's a way to just, is there a trait there that you can just, by plugging in the...
It's pretty specific. So I had, there's the version case class, which had the major and minor. And then I assumed there was this version dot validate, which took factory, which would be in the companion object of the case class. I feel like that's a decent place to put it because you wouldn't want to produce a bad version, so why not put the validation logic as close as possible to the definition of the class? So that's kind of why I put it there. You could even do lazy validation in a way, but if you define the validate version in the case class itself. Then you would create it, and then you'd produce something that's set. You'd produce the validation, which would be like, I'm going to tell you if I'm okay or not. Or you could do it in the companion object, which would be like, I'm only getting to get one unless it is valid. So you can kind of control it a little bit differently that way. Yeah?
So LiftFailKnell returns something of the right type for this akbar operator. It's got a very specific name. Are there other functions that return something that can also be used with akbar? Or is that kind of that a pairing you always use together?
The akbar part is only for, I have something like a validation, and then I akbar it, and at the end I pass in a function that takes a tuple to something else. So I had a validation A, akbar, validation B, pass it a function that takes an A and a B and produces a C. So that's the scope of the akbar. The LiftFailKnell is specific to validation, is used in validation because back to this slide, in the code for validation, how it combines two of them. So the akbar operator delegates into validation under the hood. And so in the failure case, validation's definition is I'm going to try and add failures together somehow. So it doesn't have to do with the Akbar operator directly. It delegates the hey, tell me if, Akbar operator says to the validation, do your thing. And the accumulate failures and do nothing with successes is the pure responsibility of the validation class, not the Akbar operator. Does that make sense? So they're kind of related, but the accumulating, so all I'm saying is accumulating failures is associated with validation. It has nothing to do with the Akbar operator.
I guess what I was saying is, are there other uses for the Akbar operator besides, or are there other ways that you would use the Akbar operator besides with LiftFailKnell?
LiftFailKnell is only for validation, but there's other types that interact besides validation that interact with the Akbar guy. And I can talk about those offline, I guess. Because
Thanks.
that's the applicative functor thing. So, okay, this is my last topic. It'll be fairly fast, but I think we're okay on time. Yeah, everything's cool. Okay. All right. Yes. Validation. Operations on deep data structures. It's a fancy title for something that's something not fancy at all. But I couldn't think of a better sort of title. So kind of the motivation of this is because we're in Scala, we like to do things on immutable data structures. And so we end up making case classes that contain other case classes because it's easy to make classes with case classes. And it's easy to, and they're immutable, and they have this nice auto-generated copy method on them. And then copy allows you to get a new copy of something and potentially mutate the field by producing a new version. So is everyone familiar with those ideas about case classes? So there's sort of some other issues that I'll show you that kind of creep up that are just kind of ugly. So I'm going to make this a basic tree structure. So foo is the thing I'm going to store in each node of my tree, and I just made up these fields in it. You can interpret factor as like warp factor or whatever you want. And then there's the node class for a tree. So a node has a value in it, and then it might have some children. And then you can glue nodes together to make a tree, right? I guess you can make a graph if you wanted. So this is kind of the simple thing. So let's make a tree. So I'm going to have a root node that has a name root and factor 11, and then it's going to have two children, child 1 and child 2, and they have their own factors. So let's say I have this completely arbitrary task, which you can map to whatever arbitrary task that you work on a daily basis, that I want to go into the second child and multiply its factor field by 4. You know, your boss wants a function that does this. I don't know. It's very important. Or, like somebody, convert the second child to the metric system from whatever. We do this stuff all the time, actually. Or change, replace the type of the, if it was more generic, replace the type of the third child to this other type and base it on the input of the existing value. We do these kinds of things all the time. So here's how you might do it sort of the normal way, the crappy way, the hack way, the unfactored way. But this kind of describes what you might do. So I want a thing that goes to the second child. I want to produce a new tree because we're in Scala immutable land. And we don't mutate things. Mutation is bad, which is correct. So we need to produce a new tree. But we got to go find the second child, and then once we find the second child, we got to go find its factor field, and then we got to multiply it by 4, and then return the rest of the tree as is. So I'm just going to make a function because functions are good, and then it's going to take the old tree and give me a new tree. I got the root node. I'm going to copy it, so I get the whole tree. And then I'm going to sort of I'm going to alter the children of the root. So I'm going to find the second child. I'm not doing any error checking, so this code is not correct. So index 1 is the second child. I get it. And then I'm going to I want to update the guy. I want to update that guy. So I got to get the guy out first, and then I'm going to update the children list. So like swapping in my mutated guy, mutated, scare quotes. So I need to copy that one where, and that's a node. So I got to get the value out of it, and then I'm going to copy that, and then I'm going to get the factor, which is the thing I need to multiply out, and then I'm going to multiply that by 4. So there's all this repetition in here, as you notice. So there's lots of copies, and then I have some temp variables because I'm trying to reuse some of this stuff, and I got to do second copy, and I want to alter the value, but you wish you had like an underscore here to kind of get it for free, but you don't, so you got to reference second again to get the actual value to do it. And so it's not so hot, right? So, if we were to refactor this into kind of its parts, we're going to have some function thing that gives me the second child. Okay, that'd be cool. Then I can rip out that part of that nasty chunk of code. And I might have some I might have another thing that pulls, so now I have the node. There's a function that just pulls out the value. So now I can kind of poke into the second child and then poke into its value. And then I have this other thing which takes a foo, my class that's in the node, and pulls out the factor for me. And it would be really cool if I could just tie those together to sort of point into the thing that I really want to deal with. It's like the path to the thing I want. It's the address of the thing I want. So this is like something that I'm going to fill in the blank with. And then I could just say, well, go to the second child, get its value, get its factor, and then I have this thing. And so when I sort of poke into this tree, then I'm just going to get that 2, which was in that child node. That would be cool. I don't have to do all that stuff. But also, I could do things like I'm going to produce a new tree where I'm going to like set the value to 8. Or, for our actual task, I'm going to modify this tree. And because I have sort of a handle on the thing deep in the structure, I can just say, oh, well, that's what it was. Multiply it by 4. And then this guy just produces my altered tree. That would be really cool. So we can do that. Sort of is the benefit clear? It would be nice, rather than kind of this stuff. Yeah. So that's what this thing called a lens is. So the metaphor is like I have some structure and I have like a glass lens and Newton's light is going into it and it spreads into a rainbow and you can get some little part of it. So you're zooming in on your data structure, your class. And so like to get the second child, so a lens to the second child is sort of the top thing up there. And if you kind of stand back and look at what this is, well, the first argument to the lens constructor it's like a getter. So the underscore is probably the node, and then it just calls children1, which gets the second child. So that's like the getter. I'm going to get the second child. And just like if I had a node and I want to get the value of it, which is of type foo, because foo node contains a foo, then I just, I have my node and I'm just going to pull the value out. And then if I want to address the factor field of my foo class, that's kind of like a function that takes a foo to an int. And the getter for that would be just foo.factor. So the first argument is the getter, just like you would write in Java. And then the second one is the other one. It's the setter. So if I was to set a new value into these case classes that I've made, I'm essentially just using I have like if I wanted to set the value of a node with a different foo, so the input, I would need the node that I'm going to so-called mutate. I'm going to produce a new one. And I need the value that I'm going to set into it. And then all I do is use the copy method that I already have to produce a new node with the value replaced. So a lens, all it is two functions, a getter function and a setter function. And what's going to be cool, what's going to be cool is we're going to glom them together, and it's just going to work to then go into the tree and pull the values out, and also mess with that value, and then get back a whole new structure that has that value changed, which was the original motivation. So this is kind of what I just said. So the constructor of a lens, you provided a getter. So you're pulling a view out of a thing. That was kind of one way that I thought about it. So you have a function that takes a thing to a view, and then you provide a thing with a new view, and you get back a new thing. And so and then you have lenses, and the apply means get, that invokes the getter, and set invokes the setter. That makes sense. So then there were those question marks. You can combine them together, the magical compose word. So now I have a lens that first goes to the second child in the tree, then then you have a node, and then it goes into the value part of that node, and then it goes into the factor field of that node. And now I can point that deep way. So then, if I use this combine thing, I combine those sort of refactored parts into this one new lens. So now I pass a tree into it. This second factor is the guy who goes deep. So then I get back 2, which is the deep value right there. That's pretty easy. But the cool part is the other way around. If I say modify this tree, and with whatever you find deep in that tree, multiply it by 4, so it's going to first use the getter to get down there. It's going to see the 2. It's going to multiply it by 4 and produce a new tree where just that thing has been changed. And now I have a new tree which has been modified. When I saw that, I was like, that's cool. So you just sort of glue the things that find what you want to update. There's some caveats built into it, of course. But once you can find the thing, if you follow the rules, then you can produce a whole new structure where just that part has been updated, which I think is pretty cool. Does that make sense? So kind of the pros and cons of these things, you can just combine them together. So almost for every case class or every kind of data structure that you have, you can make some lenses that exposes some part of it. And then you can glue those lenses together. So if you ever had if you had a B nested inside an A and a C nested inside a B and optional D's inside of the C, you could just point at the thing you want to interact with and interact with it using a lens without having to do all this copying and other things. You kind of are encapsulating the idea of addressing something. But you can also do this mutation, which is so-called mutation, which is pretty cool. The thing is, you got to write these guys out. So right now in Scala. So you got to type this up. Because if you think about it, the compiler already knows this stuff. When it makes the case class, it knows the names of each of the fields that you used. It knows the types. And it could easily produce that setter code because it's just merely whatever.copy replace the value with the value. And there is a compiler plugin that will generate these automatically, but I would say just do it by hand and for now until that is sort of baked into the language. Yeah?
How can you use it to change two things?
That's a very good question. I guess I'll briefly answer it because maybe there'll be, maybe not. Okay, so let's see, how would I change two things at once? So I can address something here and I can address something here. So then I have the two lenses. There's a way, so again, I think it's going to be, the way I think it's going to work is just kind of like the Akbar operator where you make a tuple. So then you have, so if you had a lens that took an A and pulled out a B over here, and then you had an A which pulled out a C over here, you could combine those together so you had a lens that took an A and produced a B, comma, C as a tuple. Then you could replace that tuple outside, and then that would affect these two things at once. Does that kind of spatially make sense? I think that's how you could do it. I don't actually know, but that's how I would start out. So rather than, I mean, you could do it sequentially, so kind of turning two things at once. So you could modify this guy first and then do that one. But if you want to be fancy, maybe you pull these out as a pair and then push them back. That's kind of how I think about it, and I think it'll work. Yeah.
Hi. In your composition of second to value to factor, it creates a sense of second and value happening. Factor is the one that causes a change. So I was wondering if you could put a fine point on how factor is in fact happening at the right moment, because it's a little hard to see that change, that multiplication is happening and getting set into value. Yeah.
So because we're lining up these lenses in that way,
Maybe from the perspective of their implementations, like the slide you
well,
put up
it's not even that, because if you just look at this,
yeah.
Factor is just like, I don't know what I'm doing. I'm just sitting out in the space, and if somebody gives me the foo object, I know how to look in its field and produce a factor. It doesn't know anything about foo being in a tree. So you could view it as just a function sitting there, or the getters and setters. So when you link them together with the and then, that's just connecting the output of one to the input of the other. So to me, I don't know if I quite understand, because if I view these guys just not having context about each other and only having context when you connect them with this and then, the and then is essentially feeding the output of one to the next guy. So factor in this case is only operating on something that has a second that has a value. So there's no way it could act on anything else. It's kind of I just kind of stated it a different way.
Yeah, I accept it, but I don't
Okay.
see it. Yeah.
Well, think about it as like a Unix pipe again. So, or like even with the lens analogy, you're zooming in and zooming in and zooming in, but the third lens depends on what the second lens was looking at.
Okay. So in terms of the implementation of value, you get the sense that the copy has already happened because the copy is in the implementation of value. So when value combines with factor with and then, what is happening in relation to that copy inside of value?
Right. So if I'm invoking modify on that tree, if I'm doing this case, so the first thing that happens is second, and second modify means give me a node with where the children has been changed, and specifically the second one's being changed. But I can only get the second value I know that I'm linked to the next guy, and I can only get the second value once I invoke the modify on that thing from the next lens. And so the copy of the children can only complete once the new second child guy is finished returning the modified second child.
Okay.
That's how it works.
Yeah.
And the value of the second node can only return its new value once the factor guy completes.
Okay.
So that's how it copies all the way out. Yeah.
I was just going to say, if it's not quite clear looking at how it's evaluated, one thing to look at is the types.
Always look at the types.
And you have 3 different types, and so you know which one is going to be used.
Yeah, if you look on the cheat sheet, it shows what the types are for when you say and then. So if you have a thanks for mentioning that. If you have a lens of A to B and then B to C, it produces a new lens that's A to C. So it's as if they go away, and you just have a direct link to the inside. So that should help also. So those are all the topics I had. I stole a lot of material from these people, but check them out. These are kind of the other tutorials I've found that don't go too much into monads and other stuff. But they do, which is okay. This talk is on GitHub. My username is arosine, and then you can check that out, and the cheat sheet's there if you want a PDF. And I'd be happy to talk more. So thanks very much.
Wow. We're in no hurry. I thought that was fantastic. Thank you very much. And I'd like to encourage more questions. Okay, you're closer to me.
My question is more about how big are the benefits? Because I can imagine, for example, using the lenses, maybe you're in some really nested structure, and even though the types line up in all the lenses, maybe the order messes up so that it actually fails at runtime. And everything's being dealt with Scalaz implicits, and how crazy are the errors, and is it kind of worth it to explain to all the new people what's going on?
Right. So I guess it can get hairy, just like it's really easy to make unreadable code even without Scalaz. So I guess one general way to answer your question is I've tried to show examples that mostly make sense upon inspection, except for the validation is the hardest part, but at least it has, I think you only really need to know like 2 or 3 things, and then it's okay. Or like the syntax things, like, okay, I can guess what that does, and then I can inspect the type if I really want to know. So I've tried to emphasize the parts that have less surprise. But then for the applicability, I think the validation is kind of a solution that other languages have been needing. Like in the Java world, there's all these ways, like maybe it's an annotation that you add to the class that expresses the constraint you're trying to do, and then there's an annotation processor that scans these things and generates some code and blah, blah, blah. We've been looking for something like it that exists somewhat more naturally in the language itself. And in Scala, that means it's a type versus these glommed together kinds of things. The lens, I don't use it everywhere. I've used it in places where I kind of have this problem where I just need to twiddle a few bits, but it happens to be a little bit farther down, and I get that ugly code block that I wrote. And so it's more of I wish I could refactor these things that I'm going to chain together, and creating a lens is pretty easy. I just do the getter and setter, and then I know what's going to happen when I stick them together. So it's mainly like I see for those syntactical. In a way, you could argue that lens is best when you have this syntax mess, this deep nesting of code that's hairy and interacting in weird ways. you know, it's good for that kind of a problem. Just like, or if you don't like the upper class type names, there's these nice little dot whatever operators like dot sum that just make it, you know, that much easier to read. Then I would use them. So that's the applicability. The applicability is more in the readability, I find. And you get these other nice things for free, too. And I would say validation is the other side where it's kind of a solution. To me, it's a solution I've always wished I had before, but now I kind of understand enough. Or there's this nice type which will do it. And it has the properties I like. It accumulates failures. Whereas, like if you look at the Google Juice code, like they have their own version of that, and it, you know, you might implement it as throwing exceptions and catching them and adding it to a thing that accumulates the failures, and that's just messy.
So that's a very clear explanation of the kind of benefits you could see from this. But I was wondering if you've had any kind of pushback from colleagues in code review or anything like that when you break out these constructs.
Well, part of it is I can get away with it because part of my role is to kind of so I didn't explain how we use Scala at Box, so I'll just digress for like 1 sentence, 2 sentences. So our front end is PHP, but our back end services are becoming Scala. And so my job has been to figure out the base architecture for all the back end services using Scala. So I built something like Coda Hale's drop wizard, essentially, in Scala. But my job is to kind of do these extra crazy things in order to say, don't go that way, and kind of collect the things that are most applicable right away. I have a luxury in that sense. Like, I'm there to fail. It's better for me to fail out in the frontier than for the rest of the settlers to you know, fall in the river and, you know, whatever. So that's one way to model it. And then, you know, so I'm, and it's part of my job to educate everybody else, like, do this, don't do that. And, like, I've been wanting this cheat sheet. Like, I have a gist in GitHub for, like, all the random crap I've collected about Scalaz that half of it's probably wrong. But, you know, I always wanted the cheat sheet with, like, practical stuff on it. And so this was a good opportunity for me to sort of collect my thoughts about that. And now I can give it to my colleagues at work and say, like, if you see the bar greater than, you know, don't freak out. It's just this. But it's a cultural thing, yeah. How do you introduce a new concept? You know, when annotations came out in Java, everyone was like, what are all these at whatevers and what's reading them? And it's kind of magic. And we kind of had to get the model of how those things are processed and when. And it's kind of the same acclimatization. Does that somewhat answer? Okay. Yeah.
Yeah, I saw this on a Stack Overflow comment today, but you just put in the code review that this code is write-only code, and you don't need to, you don't need to bother. But
well, you can do that. I mean, you can use Scalaz to make write-only code, and you can use regular Scala just as poorly, you know.
On like our Haskell, it seems like every other month there's some new treatise on, oh, we're finally doing lenses right this time. Look at this. How adaptable, like what do you think the state of lenses are in Scalaz, and how adaptable do you think that community is to staying with the pace of kind of R&D?
Well, I mean, the Scalaz guys are very experimental. They're trying to reproduce, you know, all these things in Haskell in Scala, and you know, some of it we're not ready for as everyday programmers, but some of it is. So I don't really know much. Like, there's asymmetric lenses and there's bidirectional lenses, and I don't know, you know, but I know the lenses that it provides now, and it has a particular use case that I understand. But I think as more people use Scala, like I think Scala's here to stay for the foreseeable future, and there'll be more migration from Java into Scala or other languages into Scala. So that'll push more and more. Then they'll get a bigger base, and some of those people will kind of go up and sideways to Scala Z, and more people will do that, and so the documentation might improve, and there'll be more collections of slideshows. But they're definitely pushing they're pushing out. You know, sometimes way too far. You know, they're trying to figure out. Well, they're trying to do things in Scala, but there's some things in Scala that you can't do in Haskell. So they're just kind of playing around and seeing what you can do. So think of them as your R&D lab, and you just wait till they give you a nice little chip that does what you want it to do.
So knowing what we do now after tonight from your talk, do you have a suggestion of a good phase 2 to kind of dive in a little bit more to Scala Z? Any of the ones that you listed up there, or a recommendation?
Let's see if I can log in. Next steps, what would I do?
We are actually talking about holding a workshop. And the question is it a half day or a whole day? And is it free or is it for cost? So let me see. If this was during working hours on a work day, who would be, and in San Francisco, who would be interested in a half day? 2, 4, I'm counting, 6, 8, 10, 12, 14, 16, 17, full day. 2, 4, 6, 8, 9, 10, 12. So pretty much everybody who was interested was willing to do a whole day. I know you want it for free, but could you scare up some cash if you needed to cover expenses? Got it. Okay, that's very helpful. But go ahead and give your own answer. But this is behind the scenes. There's no guarantee. I can't promise anything. There's no time frame yet, but there's discussion that's going on that subject.
So, I guess, so if you can be comfortable with kind of these 3+ things, then I might recommend then knowing the basic monads. Don't worry, it's gonna be okay. So let's see. So one example would be, I'm not going to tell you what the monad is, but so you have a method, and it has input types and output types as normal, right? And then in the middle of it, you have logger.info, blah, 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 logger.debug, blah, blah, blah. And you know, those are going to log4j or whatever. So what if you wanted to do something fancier? I'm not going to say if this is a crazy idea or not, but what if instead of the function doing the logging, which is somewhat of a static thing, it's like a global variable sitting there, what if instead your function not only returned the normal type that it returns, but also returned a log of, you know, the log level as an enum or something, and the string along with the result. And then the guy who called that method could send that to the logger, send it into Jabber, put it into a socket, you know, whatever. You know, multiple things could do something not only with the result, but with the log. It'd be like a trace rather than a log. Like if you think of like a profiler, when a profiler runs your code, it's collecting information about what's happening in that method, and it's storing that along, and then it reports on it later. So what if you could do that? That might be appropriate for some things if you wanted to kind of do more with your so-called logs. I don't know if that's kind of a toy use case, but it actually happens in some situations. Your log may be, like you may be returning some big calculation, and you kind of want to return your cheat sheet, your steps that you did, the subcomputations, a summary of the subcomputations with the result to say, oh, I used this little trick. Like imagine you have some numerical optimization, and deep in your complicated function, it said, aha, I can take a shortcut. And you just want to remember that fact. You could log it, like, oh, I used the Fu conjecture. Oh, and that might be interesting or important to someone outside of the function. So rather than just logging it, you could kind of return it with the result, like some context that describes how the result was produced, for example. Like a debugger kind of works that way. So you can do that in a really easy way with Scalaz, for example. And that's the writer monad, explained in a much easier way. So the question is, where do you go next? Is a different question. Actually, I would recommend the Haskell tutorials because there really aren't good ones for. I haven't read the monadic patterns in Scala 1. I could use a free copy, or I'll buy it. Support your authors. But there's one called Learn You a Haskell. That's really good for explaining what these monad things are like really, or like when would you use them? Because it's easy to go into the category theory, blah blah blah, and then it has no applicability at all. But I think they have a good narrative of like, what if you wanted to do this? Okay, we have a name for that. This is how it works, and then there's analogous structures in Scalaz that you could use. And because they use the best ideas of Scala in Scalaz, the syntax and the operators were probably the same name. That's what I would do. Yeah.
Another resource is to use the Brisbane Functional Programming Group, which Tony Morris is one of the heads of. Regardless of what you think of Tony, he's probably one of the best describers or instructors of how monads work, whether it's the reader monad, the state monad.
Yeah. This one is pretty good.
Thank you. That was my conference.
Although you probably will stop at page 2 of that because it goes off. But I'm sure the narrative that he had, besides the talk material, I'm sure the narrative was much clearer. But there wasn't much material on the slide.
I think he and Runar are writing a book right now. It's in early access in Manning.
Yeah, there's functional programming in Scala.
I read one chapter, wasn't really good yet.
Yeah, they're still. I think they're on chapter 5 or something. You can get in early access and check it out. But that's more. I don't know. I've yet to. I have some comments on it, but I'll leave that aside.
Do you have a Zed Shah counterpoint? Is this the future of programming, and should you quit now?
Well, I think he was misinterpreted by the so-called community.
It was a joke, right?
Yeah. I mean, but they were some of the Scalaz people were like, oh. So Zed Shah said he looked at a random file in the Scalaz source code.
Not random, it was category, I think.
Yeah, but that's like the worst one to choose.
One, right?
That's the worst one to choose.
Papa Bear, right?
And it's completely esoteric. It's like picking a graduate. It's like you're in a math library, and rather than picking Intro to Algebra, you pick, Advanced Topology and go to a random page. It's like that. And so he said, "What the hell is this?" And I interpreted he was joking. Well, he said like if this is for real, like everyone's crazy. And in that sense of going into a library and choosing some text that you couldn't possibly understand, yeah, obviously. And I wouldn't, you can go there. If I go there, I get confused because I'm not there yet, and I don't know if I want to be, but so I don't know. I thought they were touchy, and like he could have easily, if the thing is, so this is the marketing problem of programming languages. You need the right. It's like a video game. If you're playing Super Mario, like the big boss doesn't come in right away and smash you on the head, and Scalaz kind of does that. You start out and you go doing and you go doing, and then, but we don't really quite have that yet. So he went right to the boss level.
Do you have an example of a good open source code base that uses Scalaz that's sort of clean and well written and idiomatic? That would be a good example.
Yeah,
to
where do
follow?
I get my examples? That's been tough. I don't know yet. I had to like collect snippets for many months to sort of put this together.
Specs 2.
Oh yeah, Specs 2 would be good. That's a good idea. Eric Torbor's Specs 2.
I think the best tip is to Google for import Scalazian quotes and see what you get.
Yeah, that's a good one. Or in one of those code searcher things. Yeah, otherwise, I mean, you can go into the Scalaz 6 examples directory. Most of them are really hard to understand, but there's a few of them that it's like, oh, okay, that makes sense. So that's a caveat emptor kind of thing.
One more question. Who wants it?
Maybe that's it.
Was that our last question? Oh, come on. We can do one more.
You can make one up.
I have a good question, I think. On the pipe greater than and the and then is more recursive down and then back up as opposed to the composition. I'm trying to know what the difference between the two are.
There's and then on function.
You were using the lens and the and then.
Yeah.
Lens
They're
and
not the same function. Let's see, what would be a good way to describe it? I mean, under the hood, it may turn out to be just the same thing. It's just function composition. Well, compose goes the opposite way as and then. So if you said, so which is the equivalent of pipe greater than? Is it and then or compose? Because I'll get it wrong if I say what it is. It's and then?
But the pipe greater than starts with the arguments.
Ah, that's what it is, yeah. So,
In English, that means what?
so in the pipe greater than guy, the way it starts with a value. If you started with a function, you'd be passing a function into the next guy. So that's the difference of that between, and then is an operator between functions, but we need a name for that thing. The pipe greater than guy takes a value and applies the next function versus composes the functions, then versus the version of function composition. Those are slightly different. Because one is application and the other is just producing a new function. The at greater than doesn't produce a new function. It evaluates the function on the right-hand side with the argument with the thing on the left.
Okay.
It's like calling dot apply.
Thank you very much.
Sure.